Chapter 7. Ionic Equilibria. 7.1 Acid and Bases. Salt hydrolysis. The learning outcomes for this lesson are, to explain qualitatively salt hydrolysis, using hydrolysis equations, and classify the salts formed from the reaction between, A. Strong acid and strong base, B. Strong acid and weak base, C. Weak acid and strong base. In this video, you will learn the last part of salt hydrolysis, for salt of weak acid and strong base. Now let's take a look at salt, from weak acid and strong base. The salt formed from weak acid and strong base is called basic salt. Only the anion from this salt that will hydrolyze. For example, sodium acetate, CH3COO(Na), and sodium carbonate, Na2CO3. Let's look at an example from this type of salt. Sodium carbonate is formed from sodium hydroxide, reacts with carbonic acid, where sodium hydroxide is a strong base, and carbonic acid is a weak acid. Then, when the salt, sodium carbonate dissolve in water, it will produce carbonate ion, CO3 and sodium ion, Na+. Carbonate ion act as Bronsted-Lowry base, by accepting a proton from water, while sodium ion does not hydrolyze, as it is from a strong base, which completely dissociated in water. So, carbonate ions will undergo hydrolysis with water, to produce bicarbonate ion, HCO3-, and hydroxide ion, while sodium ion does not hydrolyze with water. Hence, the anionic hydrolysis of carbonate ion, produce more hydroxide ion, which result in formation of basic solution, with pH more than 7. Now you try for salt sodium acetate, CH3COO(Na). Firstly, write the dissociation equation for sodium acetate. Sodium acetate when dissociate in water, it will produce acetate ion, CH3COO-, and sodium ion, Na+. Some hint: acetate ion is from ethanoic acid, or called acetic acid, which is a weak acid, while sodium ion is from sodium hydroxide, which is strong base. Therefore, sodium ion does not hydrolyze with water. Only the acetate ion that will hydrolyze by accepting a proton from water, and produce ethanoic acid, and hydroxide ion. As the anionic hydrolysis of acetate ion, produce more concentration of hydroxide ion, OH-, the value of pH become more than 7, which makes sodium acetate as a basic salt. Take a look for another example of anionic hydrolysis.
The deadly poison, potassium cyanide, is a salt. It dissociates into ions in an aqueous solution. The cyanide ions, according to the Bronsted theory, are an anionic base, and react with water molecules, which act as an acid in this case. The concentration of hydroxide ions in the solution increases, which results in the alkalinity of the solution. Thus, cyanide ions behave like bases, characterized by a dissociation constant Kb. Other salts of weak acids and strong bases hydrolyze in a similar manner when added to water. These include sodium benzoate, commonly used as a food preservative, or sodium nitrite. Anions of these acids behave like weak bases, forming hydroxide ions in the reaction with water. Anions of strong acids such as nitric acid, hydrochloric acid, sulfuric acid, do not react with water, because the chloride, nitric, sulfate anions are extremely weak bases, which do not react with water. Generally, we can say that all salts, formed by strong bases and weak acids, hydrolyze to give alkaline solutions. Note that a hydrolysis reaction can be considered to be the reverse reaction of a neutralization. However, not all neutralization reactions can be reversed. For instance, the neutralization of hydrochloric acid with sodium hydroxide is virtually irreversible. This is why sodium chloride, as a salt of a strong acid and a strong base, does not hydrolyze.
These are the summary for lesson about salt hydrolysis. First, for strong acid and strong base, it will produce neutral salts, where both anion and cation from the salt do not undergo hydrolysis. Next, salt from strong acid and weak base, produce acidic salt, where only cation that will hydrolyze by donating a proton. Lastly, salt from weak acid and strong base, produce basic salt, where only anion that will hydrolyze by accepting a proton. Thank you for watching this video, Salt Hydrolysis the last part. Feel free to ask your lecturer, for more understanding in this topic.